Hi you guys, my name is Marcos and I'm in the physics class and I'm going to teach you guys and I'm going to present today an example of the first law of thermodynamics. And excuse my English, I'm not the best on it, but okay, thermodynamics. Alright, so what that means, okay, it means that the first law says that the total energy remains constant for a closed system. Okay, this means that two bodies are placed in contact, one hot and one cold. Okay, the hot object will transfer the energy to the cold one. So the total energy in between the two systems will be the same as before. Okay, so what I'm going to try to prove today, okay, we have boiling water and we have regular water. I just put 15 milligrams right here of water, cold water, into the system right here, which, as you can see here, it's got the thermometer and an agitator. So we got some water in there, and the temperature that we have recorded is about 80 degrees, okay? So what that means, that I'm going to have my sample here, which is a piece of aluminum, and I'm going to place it right here with no water. I'm going to place it in there. We're going to put it on that boiling water. We're going to measure the temperature for 1 minute. 1 exact minute. So right now we're going to start counting 1 minute, and we're going to transfer that piece of metal or that piece of aluminum into that cold water, and we should have the same temperature that we had here recorded, because the thermodynamic law says that delta U equals work plus Q. So the work done is being done by the vapor and the heat transfer to the piece of metal, even though it's not in contact with water. And then we're going to transfer over here to the water, and it's going to transfer that heat into the water, and we're going to see the difference right here in the thermometer. So right now we have about a minute, and we have about 100 degrees. So we're going to take the thermometer out. We're going to turn my stove off because the heat and the electricity is kind of expensive here in Florida. And we're going to place my sample into that water that I have here already at 80 degrees room temperature. So now we're going to agitate for a minute, which is 10 o'clock. And we're going to agitate the water for a minute with that piece of metal of aluminum inside for a minute. And see what kind of temperature I'm going to get here. And I should get 100 because it's the same temperature that I have here that is being transferred with that piece of aluminum into that cold water. So, like the thermodynamic law says, the heat in between two systems is going to be equal, even though one is colder and one is hotter, or either or. So right now we are up to 90 degrees right now. We're going to keep agitating the water. And there we have it. We got 100 degrees right there. 100 degrees, which means that the law is proven. Meaning that if you have a system, hot, cold, and you got an object and some work done to it, okay, which is the vapor or the heat in this case of the vaporizer or whatever you want to call it, that means that the heat gets transferred to that piece of metal, and we put that piece of metal in a different spot like we did here, and we get the same temperature. And that's it, my friends. My name is Marcos, and I hope you enjoyed. And if you guys have any questions, you can ask me anytime. I will be here. Thank you very much. And this is my kitchen. Thank you very much. It's my lab.